Hi, I'm Malavali, Assistant Professor in the Department of Computer Science and Engineering. The first topic is the abstraction. Abstraction is nothing but the process of hiding a complex implementation and showing only the essential features of the system. The purpose of using abstractions are system complexity. The developer focus on important functionalities and improve and readability of the software. For a better understanding, when we drive a car, we see only the wheel and the pedal, but the internal functionality of these are hidden. We see only the outer essential features. The advantages of abstraction are it simplifies the system design, code reusability, and it is applicable for large and complex systems. And next is the information hiding, is the principle of restricting the access to a internal detail of module and exporting only the necessary information, which is nothing but here we show only the important information. The remaining informations are hidden. The purpose is to improve the security and to prevent access modulation of the data. The advantages of the information hiding are better modularity, easy maintenance, and mainly the security of the system. Refactoring is the process of improving the internal structure of existing code without changing its external behavior. Some of the benefits of refactoring are it improves the software quality, making the debugging easier, and also it provides a best and a quality code, and also it replaces the duplicate code. Some of the examples where we use refactoring are, if we use the same concept, we can reuse the function or the code for better improvement. Next is the modularity. Is the process of dividing a software system into a smaller and independent module. It's some of the characteristics are it belongs to a specific function. Each module can be developed and tested independently. Some of the benefits are easier development, easier testing, better maintenance, and the real-time example for the modularity is the user module and payment modules, order modules, like online system, cloth online shopping, like that is the some of the examples of modules. Then is the pattern refinement. Pattern refinements involve applying, improving a software design to solve the concurrent design problem efficiently. Some of the benefits are it improve the software architecture, promote the reusable solution, improve the software structure. Some of the examples of the pattern refinements are it's used in factory pattern, observer pattern, and so on. Next is the software architecture. We know what is architecture. It is nothing but the overall structure of the system, which includes the component interactions and the nothing but we can say that the architecture is the blueprint for designing our software systems. The component of the architecture are module, interface, database, and the communication mechanisms. And the type of architectures are layered architecture, client server architecture, microserver architecture, service oriented architecture. And some of the benefits of architecture provide, as I said earlier, it is a blueprint, it is a system's blueprint. It improves the performance and supports scalability. It provides a good communication between these systems. The last topic is the refinement. Refinement is nothing but the process of granularity, transferring the high-level design into a detailed implementation step. Some of the benefits of refinement are it improves design accuracy, help management complexity, and ensures requirements that are properly implemented. Next topic is the data flow diagram. From the word itself, it specifies how a data is move from the starting to the end, how a communication of the overall system is different. In the DFT, we have two level, level 0 and level 1. Before going to level 0 and level 1, first we see what is data flow diagram. It is a graphical representation how our data move and transfer the information to the systems. The purpose of the data flow diagram is it visualize the data movement, understand how the system requirements are classified or transformed into a diagram. It improves the system analysis and the design so that the developer can understand the requirement given by the customer. The key components of the data flow diagram are: first is the external entity. These are represented by the square. They are nothing but terminator. These are mainly used for the representation of source and destination of the data outside the system, nothing but customer system, database, like that. Some of the examples where we use these entities are like banking systems, library management systems, main part of the overall system we use the external entities. Next is the process. The process are represented by the circle or rounded square. uh, the work of process is to transform the data. Here we calculate the salary, generate the invoice, process order a process, like that. And next is the data store. Data store is represented by the open rectangle or parallel line. These store the repository of the data for the further use. Example, in the real time where we use is customer database, employee record, product inventory, like that. Next is the data flow. This is nothing but the arrow mark. It connects the entity with the process data store, like that. It is a communication between all the data flow symbols. Next is the rule for drawing the data flow diagram. We can say in two methods. One as the valid data flow and next is the invalid data flow. For the valid data flow, the external entity must be represented in the process. The communication must be represented from the process to the external entity, process to the data flow, the data stored to the process, and the process to process. The invalid data flows are: we cannot connect a external entity to an external entity. Only through external entity a process and the external entity is allowed. Then the external entity to the data store is not allowed. Data store to external entity is not allowed, and data store to data store not allowed. For each communication, it needs a process for communicating to next entity or next process. Thank you.